So in the previous video, we have seen the introduction part of this course, Databricks Certified Associate Developer for Spark. And in the next video, that is, we are taking a topic 2, which is Apache Spark Distributed Processing. Basically, so this in this video, we will discuss how the Apache architecture work internally, and how exactly it distributes the job that is given to it into a multiple chunks, and it will be able to process it in a distributed manner. So we will just explain in detail in this particular video regarding that, and this video is specifically to explain that distributed processing of Apache Spark in architecture level. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. Actual video, so this is just an important note, so please note, make sure that you are using a headphone for the best experience, so and also adjust volume accordingly, and also make sure you pause and take a notes wherever it is needed, which is actually important, and we would also recommend to watch the full video without skipping, and also follow the complete course as per the sequence in the playlist. And also it is important to practice hands-on along the course, so that you actually kind of get into the in details of it, and will able to digest the topics better. And also, any questions or any suggestions, please feel free to comment in the comment section, so I would reply with as soon as early as possible. And if you need any practice notes, notebooks, or any practice notes, so please feel free to contact me in the given email ID. So without any delay, so let's get started. So when we talk about distributed computing, so the word distributed means you are actually distributing the workload. So that is the basic meaning of distributed computing. But how exactly it works when you take about the specifics, right? So whenever there is a system or a computer node, basically, right? So definitely there will be a hardware part of it, which is CPU, RAM, memory, and hard disk and all, right? Primary memory and secondary memory, which is a hardware part of it, and the software part of it is the operating system, where it actually manages the entire programs that is given to a computer node, right? And the different applications that are running on the system will be able to utilize this computer node via the operating system, right? So this is how the computer works. I mean, the computing works in a basic way. But if you go to the so when it comes to the distributed computing, definitely there will be a multiple nodes. So it will not be one computer or one node. So it will be multiple nodes of systems, basically, right? So it might be, we have just demonstrated the four nodes here, that is four computer systems, right? And each computer systems, or each nodes that we call, is having its own CPU, RAM, hard disk, operating system, CPU, RAM, hard disk, operating system, right? And what happens is, so each of these systems will be interconnected via a network interface, right? So there will be a network connectivity between all of these nodes. So that is where we call it as a distributed computing. That means each systems are sharing the workload that is being given to them. And how do they communicate? They communicate via network. So there is a network connectivity between all of these systems. So that is where it constitute to become a one cluster, as you can see, right? And next, let's go to the detail, or next go to the next level of topics, right, to discuss more. So that is when you take about cluster, so this the entire thing what we are discussing will be one cluster. So say for example, so what we are discussing from here to here, it is entire cluster, right? And when we talk about cluster here, so this cluster will have a cluster management, right? And so this so cluster should be managed in a proper basically it should be managed. So as you see, each nodes or each systems is having operating systems, right? And similarly, so each cluster need to have a cluster management to actually kind of maintain and manage the entire operations, right? So that is where the cluster manager is important, right? And each nodes will have a node manager, because operating system cannot directly interact with the cluster manager, so there will be a node manager. So this is another program that will be running in the each of these nodes, which will be interacting with the cluster manager. So basically there is a cluster management manager uh, which will manage all the entire cluster, and each nodes will be having its own node manager. So it is like a master child architecture where one particular node acts as a master. So this is a master and all this acts as a child, right? So that's the whole story behind this, right? Uh, as you can see, as I was telling, so this is there will be an interconnection between this master and child. So like, and each child will also be interacting with each other. So basically, uh, entire this ecosystem will be considered as a distributed computing. So now let's go to the detail how Spark will use this architecture of master child or master slave, or basically we can call it as a master child or master slave, right? Or something like that. So right. And when you talk about Spark job initiation, so how does a Spark job run? So there are two steps, right? I mean, when you trigger a Spark job, how does it initiate? And after initiating, how does it execute? So in this slide, we'll just discuss how the Spark job initiates, right? So how does it initiates is like there will be Spark command. So whatever the program you write, so that will be converted into a Spark command. So this is a uh, low level of command that will execute the Spark. Basically, if you're writing any code, so end of the day, if you want to call the Spark job, it has to be internally converted into this format. So this is the syntax of calling the Spark job, which is Spark hyphen job, and after that you actually give what is the job that you want to run. What is that? Whether you want to read a file, you want to process a file, right? You want to read a columns and do some operations on those columns. So whatever job you want to run, so that job the job as a class you are giving here, and then so you give the master node. So as I told, particular master IP, whatever or the location that you are giving here. So this is nothing but uh, the IP of this master node, right? So this IP of this master node, basically, like, let me check this. Right. So this location that you are giving here for the master node, that means you are specifying where this I mean, where exactly the location of this master node, because so you are just a user here who is using this laptop or the machine to submit this Spark job, but the cluster might be in the remote location, so that you need to give the location of the master node where the I mean, where the cluster is installed, the Spark cluster is installed, and then you have to give the driver memory. Suppose driver memory is nothing but the memory of this master node. So the memory of the master node might be like 100 gigs, but you want to utilize only 10 gigs for the this particular job. So that means that's why you are giving 10 gigs, and you want to run this app. So this app can be anything, right? It can be reading a file, counting the number of words or whatever, so and so. So for that particular job, you are giving this 10 gigs, and the driver course is 4 is nothing but this particular machine or the master node might be having 64 cores basically, right? And you want to use only 4 cores out of 64 cores here, right? For this particular execution. So as you can see, it clearly you can segregate the uh, things here, like this is 1, 2, 3. So these particular three are related to the driver nodes, right? That means master node. And then next three are basically for the executors. That means the child nodes. So number of executors are four because I have four nodes here, right? So 1, 2, 3, 4. So that's why the number of executor is four, and I want to utilize all these four executors. And each executor nodes, I want to in each executor node I want to utilize 20 gigs in each executors, and each executor cores I want to utilize four cores in each of these executors. So that is the configuration when you're submitting the job, right? And once you submit a job, that's the first step number one that you're doing here, saying that I want to run a job in this master node and with these number of executors, and this is the executor configuration, and this is the master node configurations. So with that, that is a step number one. So with that step number one, once the job is submitted to the cluster, it will be submitted to the cluster manager of the master node. So cluster manager knows each and everything of each and everything of the its nodes in the cluster. There might be n number of nodes, like we have four here. There might be n number of nodes. All the node information, the resource availability, what is running in each of those nodes, what is the percentage of CPU, what is the percentage of memory. So all those details will be maintained in the cluster manager. So it knows which node to utilize in a given time, basically, right? And then what happens is this particular cluster manager gives this job to the node manager of the child nodes. And these child nodes, as a second step, it will take that job and it start analyzing what exactly is needed for that particular job to execute. So once that understands that, and so that is a step number three. And step number three, what happens is like it actually the node manager will inform the cluster manager regarding uh, how much job it will analyze the job, and it will give the stats what is needed for that job to execute. And then cluster manager will take that information, and it will trigger a notification to all of the node managers to start executing the job. Suppose the job might be a simple job, it might be read a file and basically uh, take a count of the number of words in that file. So to do that, if you kind of use only one particular node or a cluster, you can imagine it might take like if it is a 1 GB of file, say for example, it might take 10 minutes. If you are distributing that load, that means instead of one node doing this, reading the file and doing the count of the number of words, here you are giving to the four different nodes. The cluster manager is giving the task to the four different nodes, right, via the node manager. And each of the nodes will take the task from the node manager, and they will start its own executor process to start processing that particular file and start counting the number of words. So basically what happens is we have given the number of executor four here, but that doesn't mean that it has to use number of executors four. So this is the like what happens is at a best scenario we are using four executors here, but in a given time this particular node might fail. In that case, the manager will recalculate the effort that is needed to do that particular task, and it will again redistribute the work among the available three nodes in the cluster. So basically cluster manager is something knows the health of each nodes, and the resource availability of each nodes, and the health particular of each nodes, and whenever there is a failure it actually acts and redistribute the job accordingly. So that's the whole duty of a cluster manager of the master node, right? So and then what happens, right? And so that's the fourth step where the cluster manager is submitting the job to the task to the node manager, and the node managers will create the executor process and will start executing the job. And once the job is So I mean, basically, it starts the job here, right? It is actually not processing. It just it creates the executor process, but the job is not yet started. So then what happens is there is a last step where cluster manager will tell this node manager to start the job, because cluster manager has got the information that okay, all these nodes are ready to execute, and once it gets that flag that all these node managers are ready to execute the job in a distributed manner, so then the cluster manager will tell this node manager to initiate the job. That is when the Spark session will initiate. So this is important. So whenever the Spark session will initiate, so then exactly where your Spark job will start execution. So this is about just about the Spark job initiation. So this is not the end-to-end execution life cycle. It's just the initiation life cycle, right? So once this is done, so the Spark job is initiated here, just initiated, right? So in the next slide, we will move to this next slide where we will understand the execution part of it. So we're coming to the execution part of it again. So as you see, like there is a cluster, there's a master node, there is a slave nodes, master or child, master or slave, whatever you can call. And then the Spark session is already initiated, right? And once the Spark session is initiated, each there will be a job logic. So job logic is in our case, you can take example of reading the number of words in a particular file. So that is a job logic, and that job logic is a program. So that program will be split into multiple tasks, right? And each task will be given to the each executor process, which are ready in each of the nodes. And say for example, this task will read the file which is partitioned, like one file is partitioned into as four uh, into four parts, and this is calculating the task of this node is to read the number of words in a file which is a part of the main file. Similarly, there might this particular node might be reading the second part of the file. Similarly, this is third part of the file, and this task is fourth part of the file. Basically, one particular file is split into four parts, and they have distributed the job of reading the number of words uh, in that file, and they start the execution of their job, right? And once the job is executed, what happens is it will give the result back to the uh, cluster manager. So suppose this is giving that okay, this word count is 20, and this is and the third node might be giving 40, and fourth node might be giving 50. So basically all this task will return the count back to this job logic, right? And this job logic will take the count at the end, and it will aggregate the count, and it will produce the overall count or the final count of the number of words in a given file. Basically this is the power of using the distributed computing, right? So instead of if the job is taking 1 hour, right? So if you distribute it into multiple nodes, it might take 10 to 15 minutes because the workload is distributed here. So that's how the Spark architecture works in a distributed manner. So moving forward, so there are different modes of Spark job execution. So the in the previous explanation, whatever you've seen, so we are taking by default it is a cluster mode, right? So this whatever I talked is about the cluster mode where there is a cluster and you are submitting a job to a cluster and it is executing. But there might be a different way how do you execute your job. So by default it is a cluster mode, right? And you can also use the client mode, and also you can use the local mode. And so basically why there are different kinds of mode, right? Local mode is nothing but if you don't have any cluster, right? You are just practicing, right? And if you don't have any cluster installed, so your laptop or your machine where you're executing the job will become the your cluster. So where your master node and child nodes or everything will be in the local mode. So this is basically for the practice, right? individual level where you're doing a practice, and the client mode is also for a if you're doing a programming in a debug mode, or as a developer you are just trying out multiple things. So then also you just execute in the client mode. So we will see what is client mode. But in the production scenario, right, when you deploy the code into the production, so then definitely it will be the cluster mode. Okay, so we will discuss anyway in details regarding all of this. So first, let's discuss about the client mode. So client mode execution, how it works is, so as you can see, you have to specify explicitly the deploy mode is client. That means you are a client here, right? So executing here in this as a user, you submit a job, right? So as a user, you submit a job. What happens? So this is a client, your laptop or your machine, right? So the driver, the Spark driver or the Spark session will be initiated in your machine itself, not in the cluster. So this is the entire cluster, right? So, but the job driver, the Spark driver job is not executed in any of these nodes or any of the master nodes. The driver is executing in your laptop or in your machine where you are triggering the Spark job. So, and your Spark job is your laptop is responsible for the basically the execution of the job or maintaining the job in this case. So, so yeah, again, we cannot run the high-end jobs here because your laptop or your machine has might have a limited amount of capacity of CPU and memory. So this is just for the small jobs you can use. And why we do this is it will be much quicker to execute in a debug mode or something to try out different things as a developer. So in this case, you use a client mode, right, which will be little quicker to execute, and it is it is only recommended for the small jobs, right? If it is huge jobs, your laptop or your machine might get crashed because it is not a sophisticated machine for the running that huge amount of jobs. So you need to be very careful when you're running this kind of jobs, right, in the client mode. So once you submit a job, it will go to the cluster manager, and cluster manager will take care of all the story that we were executing or explained in the previous slide, right? So there will be executor process, and then once the executor process completes, so you will get the result back to the Spark driver. So that's how the client mode works. And what is a cluster mode? Cluster mode is nothing but that is what we have discussed in the uh, by default it will be cluster mode. So cluster mode is nothing but, so this is your machine, right? But you are just submitting the job here from this is your laptop or system. You're just submitting the job to a cluster. So this is the entire cluster. And once you submit a job to a cluster, your job is done. That means even though your laptop or machine, so even though you turn off your machine, so that will not impact here because it is a cluster mode, and so the job is actually executing in the cluster, not it is not maintained by your laptop. So once the job is given to the cluster, it is like a fire and forget. So it just fire and forget. That means so it doesn't matter if even though if your laptop or machine that you submitted a job will go down. So even though even in that case your laptop is not available, or you turn off the laptop, even in that case your job is continuously executing because it is already submitted to the cluster. But in the client mode, if the job is uh, if the laptop is turned off, your entire job will be interrupted because your laptop is acting as a driver node there, which is actually maintaining and managing the entire job life cycle. But in this case, it is not the case. So in this case, it is a cluster mode. So entire job is once the job is submitted to cluster, so the cluster is taking care of everything. So this is generally the production scenario. You actually use this kind of mode where you schedule your jobs, and so no need of this particular client where you need to keep your laptop turned on. So there is no need of that because cluster is taking care of everything here. So and once that is done, and so in this case this driver node is driver job, or the Spark session is working in one of the nodes. Like unlike the cluster client mode, where the client in the client mode case, the particular Spark session and Spark driver was here. Basically, Spark session and Spark driver were here, where that is the whole reason if that particular laptop or the machine goes down, so entire thing was going down. But in this case, so it is maintained in one of the nodes within the cluster, this Spark session and driver, so it will not disturb any execution, right? So that's the cluster mode for you, and I hope you understood the difference between cluster mode and client mode. And the last one is the local mode. So in the local mode case, where you have to specify here something called as master local. So as you can see, this is one machine, and inside this machine, everything is there. That means the master node, child nodes, everything is there. And so this basically what you're telling here is I don't want to use any other external resources here. So I use my laptop or my machine desktop as a cluster, and even we know that we don't need an internet here, an internet connectivity, because we are just using the local machine as the for our processing. So this generally will be using as a developer to run a small code here, small level of code to just practice, right? And it cannot be used for any definitely for a production scenario, because here we are talking just about the laptop or desktop. So and so this is just for a practice purpose again, right? And this is basically the difference between local mode, client mode, and cluster mode. Hope you're able to understand and how do you trigger and what is the command difference and what is the execution difference, right? And once this is submitted, definitely like as usual, entire thing is happening within your laptop or within your machine as the picture shows, right? So quickly jumping back to the driver process, jumping next to the driver process and executor process. So driver process will compute the resource requirement, and it also manages end-to-end life cycle of a job, including dynamically increasing and decreasing the resource consumption. Distribute and schedule the work across the different Spark executors. Any failure, it manages the nodes by requesting alternative resources from the cluster as available and as needed. And also it keeps track of all the executor processes and its progress, and it interacts with the program input. So executors are just taking a command by the driver nodes, and it executes the tasks that are assigned by the driver, and report any status, success, failure, in progress, all the status back to the Spark driver. And it updates health basically to the driver, like in a timely manner, that is any failure or availability of its resources, right? It keeps on communicating to the driver. Basically the driver process is installed in the master node, and executor process are installed in the child or slave nodes, and there will be a continuous polling between this driver and driver process and executor process, that is master and childs, master and child, or master or slave. Basically in this communication, all this information will be exchanged, right? So what exactly need to be executed, and if executor completes the job, uh, what is the success, or what is the status, success, failure, or in progress. If the executor is failing, or if the executor is going out of its resource, everything is actually is being continuously updated to the driver node, and driver node or the driver process will take the action accordingly to redistribute or recalculate the workloads among the available nodes. So with that, we come to the end of this video, and so we have explained how the Spark make use of the distributed computing with respect to architecture, and how the job can be split in a distributed manner, and uh, it can be the execution can be much faster. So hope this was useful. Thanks for watching.